Hi guys. Um, I was informed I can start, so I'm starting. Uh, Today I'm going to talk about different ways to deliver information from the server to the client. But before that, I would like to get to know you a bit more. So I'll be asking the general questions like, what are you guys doing? And you're going to raise hand if you're doing it. Okay? And I promise I have t-shirts to give if people are complying with this. So, okay. How many of you are doing JavaScript on the backend? Me too, actually. On the front end? Oh, full stack? Like, okay. And how many of you has been using long polling, for example? Okay. And push, like WebSockets? So most of you are doing actually WebSocket applications. Wow. Okay. So first, a few things about me. I'm Martin. I am currently an ongoingly tech enthusiast. I'm working as a software architect at SB Tech, and I generally have background in computer science and in sports betting. And I used to be a graphic designer, and it's hard for me to be smart. And I want people to know it. So if I make mistakes, just correct me. Today I'm going to cover a few topics, and I'm going to try to make a technical demo if I don't receive blue screen of that. So I will start with actually a business case, because we need to know what we're implementing in order to understand the decisions that we're making. Then I'm going to cover the different possible implementations of this business case, and I would do a demo. Now, Harry and Douglas made a very interesting case about performance and paradigms today and yesterday. And you need to understand that everything that I'm going to show you today is because we want to make our application faster and more accessible. So we are not just doing it because there is something new to try out. So what is the business case? Imagine we have mobile application, any mobile application. As a business, we need to be fast. We need to react fast on the ever-changing market, which means we want to release less software. We want to release as much software as possible, as fast, meaning that we're releasing less instead of releasing huge chunks. In order to do that, since we're delivering huge amounts of data from the backend, we need to somehow streamline this process. Now imagine that my application, my beautiful application here, has a few different, let's call them widgets. Those widgets, every single one of them connects to some resource and gets data and updates in kind of real time. So if I'm using a technology which makes 3 connections for those 3 widgets, that's not really okay. So we are trying to make something like that. We want every widget or entity on our page to make a request to our network and get a multiplexed response. Do you know what is a multiplexing? How many of you? Okay, so multiplexing is a very nice concept. Imagine you have like a pipe, and you can transfer only one resource at a time in this pipe. This is generally how a connection works. You request a resource, you open a pipe, the resource comes to you. But with multiplexing, you take a big axe and you chop the resource in few pieces, and you start putting first resource, second resource, third resource on the same pipe, and you send small packets of the same resource over the same pipe. Meaning that in this way, we are going to get only one HTTP connection, and all of our data is going to stream through this connection. So we will not waste resources in vain. Now, one of the reasons this is important is because, on general, when you are establishing connections, you'll waste time and battery. And we're still talking about mobile devices. So we need to minimize the resources we're spending in order to optimize our performance. One of the ways to do multiplexing on the web is using HTTP2. Do you know what's the main difference between HTTP2 and HTTP1? Multiplexing. There are other differences as well, but in our interest, multiplexing is the most important one. So, there are many ways to achieve taking data from the server to the client, and we don't know which one is the best one, right? How many of you think that they know which is the best one? Okay, good, because nobody does. Okay, so what we have three main options. We can do variation of polling, either long polling or short polling, doesn't matter, it's polling. We can use sockets, or we can use server-side events. So how do we know what we do, what we want to do? Well, just do them all and see what's the difference. So, without further ado, let's start with long polling. Now, long polling is the equivalent of the child on the back seat that's asking, are we there yet? Are we there yet? Are we there yet? So you do different things to make it ask the question less. For example, tell him, count the corners. We are going to be there in 50 corners. And after 50 corners, the child asks again, are we there yet? And so on. So eventually this concept it works. But when you want to transmit a lot of data in small amount of time, eventually you start wasting data. And what I'm going to cover is I'm going to cover the big reasons why we are not using long polling, for example. So one of them is header overhead. In short, what happens is that every time you do long polling request, it's a full request. So you're sending your full set of headers, full set of authentication if needed, and so on. And you're getting a full response. Meaning that we can actually get a case where we have 15 kilobytes of headers. Just imagine a general JWT token. It can be in base 64, it can hit 10K easily. So you're transferring 15 kilobytes of headers backward and forward to get 1 or 2 kilobytes of data, which is the funny part. And every time you need to do this, you need to actually establish a new connection because you've waited some time and the connection is closed. So to avoid header overhead in long polling, you can basically do nothing. You can try to compress stuff, you can try to send as less headers as possible, but eventually you're hitting a point where you just need to transmit the headers. The other thing is the maximal latency. So how many of you know what is retransmission? One guy? Nice. It's Hari. Okay, we don't count Hari. So when we are talking about maximal latency, every time you establish a new connection, you need to wait. Sometimes you need to resolve a resource which is in a different domain, so you need to even wait for the DNS to resolve. And this delays your data, and it delays it in many ways over the mobile network. Because when I'm moving around with my phone, how many of you use your phone in a bus? Yeah, right. So do you browse the web in the bus? Do you use some web service? Okay, so imagine you're using any service on your phone while you're moving, any connected service. So what happens is that you're constantly switching cells, network cells, because one cell in the city has general area, I think, half a kilometer, something like that. So you're constantly switching cells, but in the meantime, you're downloading data. So what happens is actually the data tries to reach you, then you're moving to another cell, then the data tries to reach you from another cell, and so on, and so on, and so on. So when you're in a fast car, or in a car generally moving fast on a highway, this is why you get this poor connection, because the message almost got to you, and then you switch to another cell. So you're starting over. So when you're doing long polling, this is true for everything, actually. This is true, it doesn't matter with the technology, but with long polling is the worst, at least from what we observed. Then we have the connection establishment. Now, you literally lose time to establish a connection. And It can be avoided if you're using persistent HTTP connection, but this is tricky. Also, it's tricky because when you're using polling, it's asynchronous. Like you're sending different poll requests and you don't know when they're going to come back. So you need to keep open connections. If they happen in the same time, you're actually having a little benefit. Additional problem is general performance degradation. Because when you're polling, the server needs to keep the data and respond to you. But in the meantime, it needs to understand what is the difference between the data that was sent to you and the new data in order to be able to send you more data. So eventually when you load this server more and more and more, it needs to handle more and more data in order to send to you. Then we have timeouts. Of course we do. But as we know, sometimes they can take longer than we want. In our case, they take shorter. In our case, timeouts with polling, there are proxies configured to close connections that are taking more than 15 seconds, for example. So you need to constantly send keep alive bit between the server and the client in order to keep this connection alive, in order to reuse it. Now, we already said that multiplexing is possible, but it's like a mirage. It's possible if everything aligns perfectly in your case, which usually never happens. So moving to WebSockets. WebSockets are kind of the opposite of long polling. You have a persistent connection between the client and the server, and you're constantly transmitting data in this connection. The nice thing is that it's a duplex connection, so the client can send data and the server can send data. The problems with this, however, are huge. How many of you raised their hand that did a socket application? How many of you had to do load balancing for a WebSocket application? From the 3 guys that raised their hand, did you enjoy the experience? They said no. Okay, we didn't enjoy it either. It turns out that proxies and firewalls are something that you never think of until it starts interrupting you. And they interrupted us a lot. I started understanding about things like proxies, radius proxies, blocked ports, crazily configured firewalls, for TCP traffic actually, because WebSockets, they are established over HTTP, but with upgrade header, which moves it to another layer. So essentially, firewall on the TCP was able to block our WebSocket connection. Not nice experience, and almost impossible to debug. Then, the famous number of connections, which for HTTP requests is like 6. Do you know how many is the number of connections possible with WebSockets? If anyone can answer, he gets a t-shirt. It's not 10,000, it's not 1. Okay, unlimited is the correct answer, so you're getting a t-shirt. I hope it's your size, because I don't know what size it is. So that's a gift, vengeful gift. Okay, so the number of connections is unlimited, which means you can handle as many connections as your hardware can handle, or your network. So let's say I have 10 socket connections on my page. As you saw earlier, all my widgets are making their own connections. So what will happen if I have 10 sockets on my page and I open few tabs with the same page? My server will be basically working for this guy. if his network connection can handle it, actually, but that's another topic. So the number of connections is something really tricky with WebSockets, and then you're getting to even harder bit, because if I don't want to have 10 sockets, I will need to manage only 1 socket connection, which means all my widgets need to somehow talk to this convoluted API, which is going to handle different requests over the same socket connection, but WebSockets do not have multiplexing, meaning that I will need to actually implement my own multiplexing or get a third-party multiplexing, but the multiplexing cannot work only on the server, because this response is going to be multiplexed on send, but something needs to understand it when it receives it. So I need to send some JavaScript to Harry's Nepali friends in order for them to decompile the response and understand what I'm sending to them. So I need to send more data in order to send more data. Then it's the load balancing. Now, with load balancing, the tricky part is when you need to move users to a new server. This is like, especially if you have a microservices backend, actually moving users already working to a new instance, first of all, it will break off the socket connection, so you need to somehow handle this on the client. The client needs to break and reestablish the connection. Then, the chain of events that can actually happen when you do that can actually trigger a massive flow of data that all of your microservices needs to gather in order to send the same data to this user. Why? Because when you moved the connection, you moved it to a separate data center in a different place. And all those already scaled architecture that you have on the back that is sending the data through one data center, you don't have it in the other one. You need to dynamically establish it. Essentially, we are moving to the point of constantly reinventing the wheel. Because with WebSockets, we need to handle many things that are automatically handled on the HTTP protocol, especially the multiplexing and the compression. Harry said that it's very good to compress your assets. It's true, I don't know why some people don't do it. Now imagine that you need to handle the compression on the server. Fine, okay. But then you need to handle the decompression on the client. Because WebSockets do not have automatic compression, it's not compressed protocol, you need to really gzip your information in the packet, send the packet, and then my phone, which I left here, needs to unzip it in my browser. Like, it's crazy. So, at that point in time, we are already in a situation where we tried weeks of work to understand what we can do and what we cannot do. And we are getting into a place where we thought of how this affects the mobile phone. So I started with the mobile phone, and I will continue till the end of the presentation, besides the demo, with the mobile phone in mind. So the mobile phone needs to establish a connection. So this is my cell. In a city, you have hundreds of those. But let's say, for the sake of the demo, now my phone has two antennas. The design of the modern mobile phone has two antennas. One is only receiving data. The other is a full duplex antenna, which can send and receive data. And this is important because the receive-only antenna is actually a low power antenna. And when you get the hardware specifications of your phone, they usually say in standby time it takes like 7 days, for 7 days of battery life. But if you're talking, you get 2 hours. So that's the reason. Because when you're talking, you're using the full duplex antenna constantly. So let's say I'm trying to open a web page because my case is connected to a web service. And when I want to do that, my phone will boot up the duplex antenna and it will try to authenticate with some network that it can catch. It will eventually do that. Then the cell itself doesn't do anything. It just connects me to a larger network. So it will connect me to the internal internet service provider, whatever. Then DNS, yada, 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 I will get to the web service that I want. So although this is vastly simplified, because networking is a vastly complicated topic, imagine this happens every time you send a request. And it is constantly established connection if you have a WebSocket. Okay? So when your request actually gets to the server, you get the response in the same way back. And this drains the battery quite a lot. So then we get to the SSE. Now what is interesting about SSE is that SSE is unidirectional. You establish the connection once, and then the server sends data to you proactively. So it's server push technology, but you can no longer talk to the server. So you're saying just send me data, and then you're no longer allowed to send anything to the server. The client subscribes, and the server starts pushing data. This is interesting because it goes only in the other direction, meaning that we can turn off the duplex antenna. Well, actually, the device is automatically going to turn off the duplex antenna if I'm not sending requests. So now we are going to move to some code. I promise it's very easy and small amount. I'll show you some client-side and some server-side implementation. If you have any questions, feel free to interrupt. Okay, so on the client, I'm creating this object of this new interface, which is called event source. And the only parameter that I need to supply is the URL. Then I do like on message event listener, and I handle the data that is coming. So that's my client-side implementation. Like literally, this is everything. Can you imagine how complicated is the server? I'll show you in a bit. But let's first show you a few more things. So on the client, I have 3 main default messages, which are allowing me to handle errors, messages, quotes, like makes sense. Then I have the ability to actually show custom messages, to handle custom messages, meaning that I can send this string as a name of event from the server, and I will be able to listen for it with the classic event listener. Now, let's go to the server. The server is like this, like literally, that's it. This is the only function that you need to handle SSE on the server. So whenever you get a request, it needs to be signed with a special header which upgrades it. It's an event source header. If you don't have this header, you cannot subscribe. But besides that, that's all. What I've written here is something that should not be handled in the same function, obviously, but for the sake of presentation, we need to set up headers, we need to write our message, and we need to send our message. So this function, if I call it with a response object, it will actually send the message. Do you know how the message is sent? Can you infer it from the code that you see? There is a t-shirt for that. So, sorry? No, not through which channel. The question is, what in this code made the message to be sent? What? Response right? No. It's a... okay. I'm not joking, this is by specification. The moment you pass this string in the message, it's sent. Meaning that I can literally have 10 lines with data. It will get concatenated, and the moment I put this, the message is sent. I have no idea why. It makes no sense. Like, from API point of view, it makes no sense to have it sent like that. I would much prefer to have a like .send or .push or .whatever method, which clearly and explicitly signs my message with the double lines, whatever. But this is like, wow. You see something here, this is this unique ID. This unique ID is important because when I subscribe for messages and I lose my connection, the second time I subscribe, I will actually send this ID to the server. And the server will know how many messages I missed, and it can send them back to me. So, let's just look at the contract. So we have unique ID, we have the event, we have this retry parameter, and we have the data. Now the retry parameter is very interesting because it can allow the server to say to the client, stop asking me for data, hold the connection, and close the connection. It means that after you do that, the browser in 10 seconds is going to actually try to reestablish the connection for data. So actually the server can decide if there is nothing more to send, and it will know that, okay, I will not have anything for this guy for like 10, 20 seconds. just make him shut up. The client implementation that will handle this code is just this. Now, it looks kind of bit like WebSockets, but it's a bit less code and a bit simpler. Something important, any other field, if you try to send additional fields than those, they will get ignored. That's it. These are the 4 fields that are accepted. Moving on, the structure of the message. You can actually create a stack of messages. As I said earlier, you are in a situation where connection got lost. And I'm reconnecting and I'm telling you my last ID is 53, okay? So the server knows how many messages I missed. They're stacked and they can be sent together, all of them together, if you do them like that. So you can create a message, concatenate, create, and then put in 2 new lines. So you don't need to send me 3 messages. You're sending 1 message with the 3 messages. Now, for the backend, there are some specific requirements. You cannot accept any header and establish SSE connection. You need to accept only event source requests. You can only accept event source requests, and you need to set up with the event stream MIME type. So that's a given. You cannot do it in any other way. You also need to maintain a list of all the connected users in order to understand what are the messages they received and what messages are the difference. And you should listen for dropped connections, so you can remove those users. It kind of sounds reasonable. I didn't do it in the first time. I had massive memory leaks without understanding why. And you should optionally maintain history of the messages, like the full history, because you can reconnect with an older ID, depends on the client, depends on the situation. Now, as usual, there are some very interesting edge cases which can make your day worse. For example, legacy proxy servers, they have a timeout. And they drop connections that look like they are not doing anything. So I have a connection, and the server doesn't have data, so it's not sending data. And the proxy decides that, okay, this guy just hangs there, cut him. So my browser then reestablishes the connection going through this entire chain, which is not nice. In order to avoid this, you can send one character string, like a command line, every 15 seconds or so. It will make the proxies think that this connection is alive. Those guys are streaming data, empty data. But anyway, you need to do it. If you want to connect different connections to users, like it's a bit more complicated, because if you're relying on an IP address, for example, let's say when a user connects, you decide, okay, this IP connected. This is not correct, because behind the same IP you can have many users. So you need to find a unique way to identify your users. So IP address is not reliable in this case. Another thing is that HTTP chunking. Do you know HTTP chunking? Okay, so for the guys that know, just keep in mind that it can have negative effects on SSE. And then if we have HTTPs per server connection, we can hit that limit. But anyway, with the promise of multiplexing, we should be able to handle that. Okay, so let's revisit a picture. This one is from a few minutes ago, when I was explaining how the connection works on general. Now, with WebSockets and long polling, on general we have this connection constantly running around. There is a feature which is called connectionless push, which is documented and not used because of reasons. The feature connectionless push means that you can actually install proxy with the internet service provider of your mobile operator and offload the entire connection to this proxy. So eventually, your server will be communicating and will be keeping the connection established only with the proxy. And only if there is data, the data will be sent at some point, meaning that you will not need to keep a connection live constantly. It will also help with this single command, just to keep alive the connection in every 15 seconds. This is basically doing it for you. Now, this is not widely used. It is actually very similar to the WAP protocol, how WAP internet was working. Additional thing, how many of you can identify the browsers that support this technology? Okay, you get a t-shirt. Yeah. Everything except IE. Now, catch. I don't really care about IE. And it's their own fault, don't get me wrong. Edge does not support this, and Internet Explorer 11 does not support this. IE 11 will never support this, obviously. In Edge, it has been under consideration for more than 1 year. But the good thing is that with JavaScript, you can actually do a polyfill. So there are polyfills for Internet Explorer. However, I don't really care because my main focus in this case is mobile. So if you notice, the entire presentation is focused on how this is handling, how this is affecting mobile use. So as we all know, the margin of usage of Internet Explorer on mobile devices is negative. It's a negative number anyway, so we don't really care. Okay, so far, thank you. Now I'm moving to a real working demo. Let's try this. The good things with working demos are that usually I get blue screens. Nice one. Okay, so I will show you client-server application. The same application is actually uploaded in GitHub, so you can download it and play with it if you want. What I have is the same thing that I had in the presentation. It's just commented a bit, and I will now press start on my simple server. Now, is this code visible for you? Should I switch the theme? Okay. So on general, you need to create some kind of web server. I'm using the internal npm package. It's nothing fancy, just to handle my requests. You see that I'm testing a URL because my requests are sent to this type of URL. And if I manage to find my URL correctly, I use this function. This function, as stated earlier, sets up headers. You can see that here I've set up. You cannot see. Why is it gray? Okay. Okay, now, is it better? Or should I switch the theme? Okay. So you can see that I've set up additional headers here because I'm running this in localhost, and browsers nowadays are pretty panicking when they see this kind of implementation working on localhost. So I'm setting up these additional headers to allow my application to query from the file system. But basically, it's the same implementation. So let's try to run it. It did not explode. So in theory, I should be getting stuff. Okay, so what's interesting here is that I have my event source object in the client, obviously. It's called CRC. So let's see what is CRC. Everything that I've showed so far in the presentation you can see in this object. Now the interesting thing is that there is a Q command. And how was it called? Close? Yeah, it's close. So I can just close the connection and that's it. This is how you manage the connection. So this is how you establish it. Just event source, my URL. This is optional parameter just for presentation reasons. What you need is really URL and that's it. Now, if I decide to send special type of request, I can just and I should be able to listen for it. For my very original event. Okay, I need to restart the server. Okay, so now you saw that my event connected just fine. And that's it. You can send different events, you can have different event listeners. This, for example, makes it very easy to implement CRUD applications, which something changes on the server, so you just send delete that, add that, change that, whatever. I want you to notice something. I will kill the server, and now the connection said it's timed out. Let me zoom in the console a bit. Nice. So you see that my browser actively tries to reestablish the connection. Like it's desperate. Please give me this, please. So if I start the server again, the connection will actually reestablish. And it will continue to receive my messages. Now this is very nice because when you start doing load balancing, you will eventually see that you're losing one connection and it automatically goes to another. So let's try to do the load balancing demo. How many of you have any experience with Nginx? Okay, nice. So you're going to help me run it. No, I did that in advance. Let's check. Yeah, I did it in advance. So this is my, this is like a home page for Nginx default configuration. Just I filled it with HTML to help me remember stuff. And this is the page which is going to try to connect to my nodes. Now I will start a few nodes. Oh, I need to run my, just a second. Okay, so now you see I have some error messages, but that's mainly because some of my nodes are offline, so I cannot connect to them. What is interesting is that I have one working node, so I connected to it. So now let's make everything else working. Second one. Nice. Okay. So now we've established a connection. You can see some letters here, A. This A means that okay. In the code, you can see that I started 5 nodes, but I'm receiving only 3 messages, right? So all those are the 5 nodes that are working. What's interesting is that I boot up 2 nodes for the first 2 addresses, and I boot up 1 node for the last one. Meaning that if I kill the first process, 1319, I should get an error because I lost the connection, and then the connection was automatically reestablished in the second node, in node B. What will happen if I revive node 1? Should the connection move? It will not move, obviously. But this is like, if I tell you how easy this is to set up, you will be amazed. Since a few people said that they know Nginx, do you want to see the configuration file? Okay. I made a typo. Now, a good way to look smart is to use Vim to preview files. A good way not to look smart is to fuck up using Vim. All right, so let me minimize everything besides this. What is interesting here is I have something that's called upstream. Is it readable? Should I increase the font? Okay, let me try to increase the font. Okay, so I have something that is called upstream. Now, the upstreams are like, in simplified terms, what's behind the door. These are my upstreams, connect them through those holes in the door. So I have 3 upstreams configured, and as you can see, I have 2 nodes working for one upstream, 2 nodes working for the other, and I have 2 for the last one, but I booted only 1, so it doesn't matter. Then I have some very, very simple configuration for the server. And since I have certificates from SBTech, I'm using them, why not? So you have configuration for HTTP and configuration for HTTPS, and I'm not joking, this is literally the default configuration. I just changed the URL to the certificate, that's it. Part of the default configuration as well. And this is the interesting part. So this is where I set up my locations. My locations are basically the URL that I want to access. So /t1 and /t2 and /t3, these are the URLs that I'm actually accessing in the client application. So if I open the source, wow. If I open the source, you're going to see that I'm connecting to T1, T2, and T3. So these are my locations. Then I do the same like in the other example, the Node.js server. If you remember, I was setting up the headers. So I'm setting up headers per location. Basically all the headers, why not? And then you set up what happens with posts and gets requests. And then you do it for the other locations. The same for T2, the same for T3. Now, much smarter people than me can do this automatically without copy-pasting code, but Nginx is not my area of expertise, so this is the best I was able to come up. Okay. So let me show you one of the graphics in the network panel. And why is it interesting? Let's refresh the page. And please zoom in. How many connections do you see here? Yes, that's the idea. So basically, all of my traffic right now is moving over one connection, only one. This is it. And what will happen if I kill a node? I refreshed the page, I was on the first node. Yep. Oh, sorry. As you can see, there was no additional connection reestablishment. You just continue using, and why? Because it's over HTTP2, because it's coming from the same source, and because of these reasons, I'm just reusing the connection and start multiplexing over it. Something interesting, the nodes behind are not all HTTP2 servers. So let's open quickly, and we're going to move to questions. As you can see, this is not HTTP2 server. But all the data that I'm doing, that I'm getting from it, is multiplexed together with the HTTP2 servers. That's because my Nginx is handling this for me, which means I can have simpler structure in my backend. I can have simple servers, simple nodes that don't know what is a certificate, they don't know what is a header, and all of this is moved to and handled in the Nginx. And this is what only SSE allows me to do. Okay guys, since we're moving forward with time, I am open for questions after a quick summary. So we've looked about long polling, we talked about quickly about WebSockets, did a quick demo on SSE. Do you have any questions on it? Yes? If the question is nice, you're going to get a t-shirt as well.
Hi.
Hi.
So those solutions that you describe, can you tell if there are use cases when you think that one solution is much better than the other? For instance, if you build chat application, maybe WebSockets will be better than the others, or because they are more or less solving the same problems, but maybe in some specific cases you can tell that.
That's actually a very good question, and you deserve more than one t-shirt, but that's not how it works. What's interesting is that with WebSockets, in theory, it makes sense to develop chat application. But what is interesting is that when you're doing a group chat, for example, the users are not as active. So one user may not be typing any messages, so why he should be keeping this connection open on his device constantly? So it makes much more sense to have a chat application implemented in this way if it's handling large chat rooms. In this case, it means that every message you type is going to be a separate request, because with SSE you cannot send data over the connection. You need to do actually new request. But depending on the performance requirements that we have, and since we're mostly aiming at mobile, it makes sense to implement my chat application using SSE just to deliver the messages in a better way, and only when users are active to make requests to send the messages. So again, depends on your use case. But real-time communication, if you think about it, real-time communication is very rarely needed. Let's say I'm delivering all my data with SSE, and I have a purchase. So the customer wants to buy something from a shopping cart, okay? It's okay to make a new request for the shopping cart. Again, it will take this additional time to establish connection and everything, but it's okay to do it in that case. You don't need to maintain open to WebSocket connection for 30 minutes just so the user will use the shopping cart once. It makes no sense. So depending on the use case, you can do very different implementations. But SSE looks very promising, and it's also been around since 2009. T-shirt? Okay, the guy did not want.
Thank you for the presentation. I have two questions. The first is server-side events. Are they different from the position of the for firewall than the WebSockets? So won't we have the same problems with firewalls? And the second question is there, from the position of mobile development, the reason is obvious. The difference is obvious because we have different antennas. But if we're developing for the desktop, is there is there a difference between server-side events and WebSockets?
Okay, so the first question is if
If there's a
the-
difference for the firewall between
Yeah, okay.
WebSockets and server-side events.
So this is like the correct answer is it depends, because if the firewall is filtering TCP traffic, server-side events are not going to be affected by it. Okay, because the WebSocket is established with an upgrade header and it's moved from the HTTP layer to the TCP layer, from the application to the TCP layer, meaning that it moves, it literally is on another level of the OCI model. So if you have a firewall that is filtering TCP traffic, you can get affected, but SSE is not going to get affected. So it really depends on the firewall.
But WebSockets are also on the TCP level, aren't they?
I'm talking exactly about WebSockets. They are on the TCP level,
yes.
but the SSE is not.
And what is the level of the server-side events?
HTTP, it's on the application layer.
Oh, sorry.
HTTP is on the application layer, right? I'm not sure right now.
First of all, thank you for your speech. And I have a question. You said later that if we open the second tab with, for example, socket connection, we will have two sockets connection. But as if I understood correct, if we made it with SSE, we will have two connections too, or no?
No, okay. If you have on the same page, in my case, in the beginning I was explaining, you can have 10 connections per widget on the page, okay? So it means that with HTTP2 and SSE, you actually get one connection. If you're using WebSockets, you're getting 10 connections. So if you open two tabs, with SSE these are two connections, with WebSockets it's 20. So WebSockets multiply if you don't multiplex them on your own.
Okay, but he has that problem with double taps and...
No. No, because with the multiple tabs, the problem with sockets is on the client machine, not so much on the server. Because with multiple tabs, you get into a situation where your machine is out of resources. Literally, your PC cannot handle anymore.
Okay, thanks.
T-shirt? And also for the firewall guy. T-shirt? Are you going to catch it? Oh, sorry.
Yeah, and also the question is about, we discussed it actually, the question is about the data compression. So we don't have compression of data, so zip on WebSockets by default, by design, yes, and how about this SSE?
That's a bit tricky. You don't have it by design in the SSE as well, but since you're going through Nginx, you can have it from Nginx. So Nginx does magic for you.
As well as HTTP2.
As well as HTTP2. Did you get the t-shirt already?
Yes, thank you.
Okay.
Thank you for the presentation. I would like to ask, did you use this in production?
Yeah.
And it's worked well?
Yeah.
And what tricky parts do you have with it?
Could you repeat, please?
What edge case or tricky parts do you have?
Well, I explained them during the presentation here.
Ah, okay.
I will, it's fine, I will repeat. It's mostly... Okay. I see half screen only. Just a second. Thank you, PowerPoint. Okay, so One of the edge cases is with proxy servers which are closing the HTTP connection. This is why we need to send empty messages, literally, messages with a command character, just to keep the connection alive, the keep alive message. Another one is with how you identify the user, because we are sending kind of personalized data to our users. We had to find, it's not like I have like a regional, I'm not taking like everybody from Germany and sending them the same content. So I cannot filter users by IPs. So I need to find a different way to filter the user and what he's subscribed to in order to keep a structure of the messages, because we are using microservices with actor model, meaning that we are trying to scale automatically and stuff like that. It was kind of tricky to actually understand which user, what they want, and in order to optimize, understand if we have users with similar type of data and reroute them to the same actors. So it was kind of edge case, and I guess most of you will not have this kind of edge case. But with personalized content, it's kind of tricky.
Oh, okay, thank you.
You have a t-shirt? Do you want
I
one?
would like to.
I think it's the last one. No, I have one more.
Actually, it's the last questions. Thanks for your speech. So if we talk about, okay, you said that we would receive the messages if we were offline, yes? So can we limit these messages? And
No, you cannot receive messages while you're offline.
You said that we provide this unique ID, yes?
Yeah.
So if we miss something, we would receive them. Is it correct?
Yes, but if you implement it in a way that you track the difference that was sent and that was received.
Okay, so I should implement this by my own?
Yeah.
Okay, thanks.
You need to understand what the user is subscribed to, what the user received, and if they loses connection and they reconnect, you need to understand if they have a diff, so you can send all the messages they missed.
Okay, thanks.
Okay, we haven't enough of time, so let's say thank you.
Thank you guys. You're free to connect with me.